Alright, so good to be back. Welcome back to my channel. My name is Setson. So today we're going to talk about object-oriented programming in Python. This is an introductory course, but you need to be familiar with the basics of Python. Otherwise, it's going to be difficult for you to follow along. This is an intro, and so we're going to look at these topics in this order. The first part, we're going to look at intro to OOP. Then we're going to look at special methods in Python, which we also call dunder methods, double underscore methods. And then we have the self parameter, which is a topic on its own. And then we have class properties and methods. And then lastly, we're going to look at pillars of OOP, which are inheritance, polymorphism, encapsulation, and abstraction. So first up, let's get into lesson one. Our lesson one is going to look at intro to OOP. What we will cover in this is going to look at what is OOP, then OOP terminology, then basic concepts of OOP, which are classes and objects, and then creating our first class and object. So the last part, that's when we're going to be writing code. But initially, we're going to look at the theory, and then of course we're going to transform that theory into practice. So let's look at the definition. What is OOP? I want you to think of OOP as a way to model the world. We use classes when we're dealing with OOP. So we have a class, which is a blueprint. We can then create objects from that class. So an object is the actual thing built from that blueprint. So everything else flows from this central idea. On this diagram right here, we can see there is a class, which is the blueprint. And then, of course, we can have an object that can be created from that class, which is the actual thing. And so this object has attributes, which are properties in programming. We can talk about the data or the state. And then it also has methods, which is the behavior of that object. And then it has a unique identity. So these are the concepts that are around OOP. Classes, objects. These objects have got attributes, methods, and then they have an identity. It's akin to real-world objects. But in a nutshell, we could define object-oriented programming as a way of computer programming using the idea of objects to represent data in methods. Here is an analogy that can maybe make things easier for you to understand. We have a blueprint, which, by the way, we call the class in our programming syntax. And then from that blueprint, we can then come up with real objects. So we have a car right here, and then we can make, different cars from that particular blueprint. So right here, you could come up with different analogies in the real world. For instance, you could say this is a cookie cutter, and the actual cookies that you make are the objects. The cookie cutter is the blueprint, which is the class. You could also think of a house plan. That's a blueprint, and the houses that you actually build are the objects that you're making from that class or from that blueprint. This is the terminology you need to use when you're talking about OOP. These are the most used terms when you're talking about OOP. The first one is a class. It's just a blueprint or a template for objects. So you can actually make objects from that blueprint. And then we have objects. These are concrete instances of a class. So we can create objects from a class. And then we have attribute, which is also properties or features. This is data stored in an object. And then we have a method. A method, these are behaviors of the object. So it's a function belonging to an object. Constructor, this is a special method that initializes new objects. Encapsulation, which is bundling data and methods and hiding the internal state. Also have inheritance, which is, if you think of it as we inherit certain features from our parents, it's also the same concept. Like the child class gets parents' traits. And then we have polymorphism. We use the same interface but different behaviors. And then we have abstraction. So abstraction is hiding complexity behind simple interface. So the last four are the pillars of OOP. Okay, so why OOP? It provides a clear structure for programs. The second reason, it makes code easier to maintain, reuse, and debug. The third one is it helps to keep your code dry. Dry, by the way, is an acronym for don't repeat yourself. And then the last part is it allows you to build reusable applications with less code. So let's look at the first skill that we're going to learn today. Is we want to understand classes, OOP classes, because these are the most important concepts when you talk about object-oriented programming. These are the building blocks of object-oriented programming. You can not talk of OOP without classes. So a class is like an object constructor or a blueprint for creating objects. Think of a class like a house plan. You can then use the plan to make an actual house. The object, not only one house, you can construct plenty of houses using that same blueprint. And then also you need to understand what is an object. Objects are analogous to real-world objects. For example, vehicles, animals, people, fruits, etc. Objects have properties, which are features. So you can talk about the number of wheels if you're talking about cars, maximum speed, number of legs if you're talking about animals, and maybe the color, etc. These are features or properties of an object. Objects have behavior. These are methods. Like for a car, you can drive it. If it's an animal, you can run, etc. Related objects can be grouped into classes. Then you can subclass All right, so we're going to get into the code now, and then we're going to create our first class. We're going to use the class keyword, and then we're going to use Pascal casing to name these Python classes. And we can then instantiate an object from the class. Instantiation is creating the object from the class that you have created. And so let's get into our code and start writing those classes. So what I'm going to do is I already created a folder on my desktop. It's called Paradigms. And so I'm going to open this in Visual Studio Code, but you could use another text editor of your choice. Let me open this. Last time I created a file called main.py. You could create another file. You can come up here where it says new file, and then you can create, maybe you want to call it new underscore class, but don't just call it class.py. It might have a conflict. Since class is a keyword in Python, it might conflict. So you could name it new class or something else. Let me name it new class, or you could name it whatever you want, main.py, but let me use new class. Okay, so here we said when we're creating classes, which is the blueprint, we can use in Python class, which is a keyword in all lowercase. And then let's say we are creating an animal class. So we could say animal right here, which is the name, and then followed by a colon. By the way, if you are new to Python, Python uses indentation. It does not use curly brackets. C++, Java, etc., they use curly brackets, but Python uses indentation to mark the block of code which belongs to a class or a function. But for now, we don't have anything to put in this class, so I'm going to use this keyword, which is a placeholder. Okay, so we said a class will bundle properties, which are features of this object that we're going to create, and the method, which are behaviors of this object that we'll create. But for now, we don't have features, we don't have behaviors, so we just write pass here. By simply doing this, we have successfully created our first class. And so how then do we instantiate? So we can create a variable, and then we use this animal class to create our first instance. Let's say we're creating a dog, and then this is a variable. We could name it anything. We can then say animal here with parentheses like this. So this variable right here becomes an instance of this animal class. If you were to print, of course, you can print the type of this dog. So we can say, we're going to clear down here. Let me write that correctly, and then I'm going to use Python, and then we have new underscore class.py, and then if I run that, you can see this, it belongs to the class animal, or to the animal class. So it's an instance of this particular class. We could create another animal. You can create multiple objects. I can create a cat underneath the dog and say it's also an animal. I can print the type of cat underneath the dog cat, save and run this down here and see whether we will get something. Both of these belong to the class animal. This is the class, and these are instances of the class. But just having this is not enough. A class is about bundling properties and methods together. How do we bundle these things together?
I have a question.
Before we write anything inside the class, we could give this dog attributes or properties. When I say attributes or properties, I mean the same thing. What does a dog have? We could say we want a dog to have legs and has got 4 legs. Maybe we want this dog. By the way, I'm using this variable that I created up here. You can assign attributes or properties to an instance of a class by using this dot syntax notation. I want this to have color. Let's say this dog is brown. So this is just a few of the properties. However, these properties are attached to this specific instance of the class. They are not attached to this instance, which is the cat. If you want to define properties of the cat, you also have to come down here and say cat dot maybe eyes. Maybe it has different properties that you want to define to eyes. And so we can then access these. I'm going to print down here dog dot legs. And it should print 4 because that's the value. Let me run this down here. You can see I'm getting a 4 down here. You could do it this way. However, it defeats the purpose of creating a blueprint, because when you create a blueprint, you want to set properties in the class. You can then assign these properties different values when you create an instance of a different animal. So instead of doing all this, we can create these properties inside the class. We could create them as class properties like legs, maybe 4, eyes. Yes, we can have 2. And so we created these here in the class. We no longer need to create them down here. We can just access them. If I say dog.legs, and let me also say cat.legs down here so that we can see what I'm talking about. So we can say cat.legs. We should be able to access that. Indeed, we're getting 4. However, there are certain properties that are different for different animals. This brings us to the next part of our tutorial. I'm going to talk about the constructor. So in our next class, we're going to look at the constructor, which is the underscore init underscore. So for today, this is the summary. We've defined what is OOP. OOP is a way of computer programming using the idea of object to represent data and methods. And then we talked about a class, which is a blueprint for creating objects, and then an object, which is an instance of a class. All right, so I hope that was helpful. If you find these videos helpful, you can leave a like, leave a comment. You can also consider subscribing to the channel. I hope to see you in my next tutorial. For now, I'm out. Cheers.